Pythagoras theorem is a relationship between the three square areas from the side lengths of a right triangle. So when we have a right triangle, the square area off the two shorter sides, these two areas must add up to the square area from the longest side. So if this is 14 squares that make up this area, 10 squares that make up this area, the small square must be 4 centimeters squared. So a squared in this case must be 4 centimeters squared. That makes this length a2, this length here becomes root 14, and this length here becomes root 10. So relationship is about the three areas, the three squares. So here I don't know the side lengths, but again I can work out the square area because I know that these two smaller areas, squares, must add up to that third area. So if I add those together, I get 94 centimeters squared. Now, there are times, and oftentimes, where we want to find the side length. But to go from the relationship of squares to side length, we square root. So if I want to know the side length of this right triangle, I take the square root of 94. That's going to be approximately 9.69. Round that to 70. Square root of 50 works out to be 7.07. And the square root of 44 works out to be 6.63. And notice that these two shorter sides do not add up to the length of the longer side. It's impossible. So these two sides do not add up to the third side. These two sides are always going to be together, will always be longer than that third side. It has to be because it's a triangle. Okay, so this is centimeters, and this is centimeters. And the relationship is between the three areas though. So how do we do this when we're trying to find out the side length? Well, we can use the Pythagorean relationship by saying the square area here is going to be 81. The square area here is going to be 22 squared is 484. This is unit squared, and that makes this square area equal to 565 units squared. And it's through this area that we can then find the side length of x. We take the square root of 565. And that's units. And if we were to approximate this using a decimal, this would be approximately 23.77 units long. And that makes about the right sense because this is 22.9. This is going to be slightly longer than 22. Yeah, 24 sounds about right. So here we can use our formula. We know that 9 squared is equal to x squared plus 5 squared, the two shorter sides. So we need to subtract to get the area of x squared. 9 squared is 81 minus the area 25. So the x squared area works out to be 56. Okay, and we still need to square root it to get the side length. So x is equal to square root 56. And as a decimal approximation, it's approximately 7.483, so we'll round that to 48.